Our solar system is made up of the Sun and a planetary system of 8 planets, their moons, and other non-stellar objects. The solar system was formed about 4.6 billion years ago from a gravitational collapse of a molecular cloud. Most of the system's mass is in the Sun, with most of the remaining mass contained in Jupiter. The 4 smaller inner planets, including Mercury, Venus, Earth, and Mars, are also called the terrestrial planets and are mostly composed of rock and metal. The 4th planet from the Sun, Mars, is the 2nd smallest planet in the solar system. Named after the Roman god of war, it is often described as the red planet due to the iron oxide prevalent on its surface. Mars is a terrestrial planet with a thin atmosphere, having surface features which resemble volcanoes, valleys, deserts, and polar ice caps of Earth. The rotational period and seasonal cycles of Mars are also similar to those of Earth, as is the tilt that produces the seasons. In 1864, it was proved that the ruddy tint of the planet does not in fact arise from any peculiarity of its atmosphere, as the redness is always deepest near the center where the atmosphere is thinnest. In 1894, qualitative observations suggested that Mars resembles the Moon, which has no appreciable atmosphere in many respects. There are 4 layers of Mars's atmosphere: the lower, middle, upper atmospheres, and the exosphere. The surface color looks red from a distance because of the rusty dust kicked up into the atmosphere. From close up, it's more of a butterscotch, and other common surface colors include golden, tan, and greenish depending on the minerals. Approximately true color images from the Mars Pathfinder and Exploration rover missions indicate that the Martian sky might also appear reddish to humans. Absorption of sunlight by dust particles may be the main reason for the redness in the sky. As for the planet's core, scientists believe that it's similar to Earth's. While Earth has an outer liquid iron core and a solid inner core, scientists believe that the measured tide of Mars is large enough to indicate that the core cannot be solid iron, but must be at least partially liquid. There are channels on Mars as much as 1,500 kilometers long and 200 kilometers wide that appear to have been cut by running water. Under Mars's present atmospheric conditions, water cannot exist as a free liquid on the surface. It must be gas or a solid. Therefore, evidence for water erosion suggests that the Martian atmosphere may have been more dense in the past. The surface also has large canyon systems. The largest is Valles Marineris. This enormous system of canyons appears to have been formed mostly by local tectonic activity rather than by erosion. Mars has 2 known moons, which are thought to be captured asteroids. Both were discovered in 1877 and named after the characters Phobos and Deimos, who in Greek mythology accompanied their father Ares, god of war, into battle. Ares was known as Mars to the Romans. And although Mars is smaller, at 11% of Earth's mass and 50% further from the Sun than Earth, its climate has important similarities, such as seasonal changes, the observable presence of weather patterns, and polar ice caps. The Martian polar ice caps consist primarily of water ice, and further ice is contained in Martian surface rocks at more temperate latitudes, also known as permafrost. Although a small amount of water vapor is present in the atmosphere, there are no bodies of liquid water on the Martian surface. Current conditions, as stated before, do not support long-term existence of liquid water. The average atmospheric pressure and temperature are far too low, leading to immediate freezing and resulting sublimation. The terraforming of Mars is a hypothetical process by which Martian climate, surface, and other known properties would be deliberately changed with the express intention of making large areas of the environment more hospitable to human habitation, thus making human colonization much safer and more sustainable. The concept of terraforming relies on the assumption that the environment of a planet is able to be altered through artificial means. Also, the feasibility of creating a planetary biosphere on Mars is undetermined. There are several proposed methods, some of which present prohibitive economic and natural resource costs, and others which may be currently technologically achievable. One of the main issues to terraforming Mars is that Mars lacks a magnetosphere, which poses challenges for mitigating solar radiation and retaining atmosphere. It is believed that fields detected on the planet are remnants of a magnetosphere that collapsed early in the planet's history. The lack of the magnetosphere is thought to be the reason for the planet's thin atmosphere. The solar wind interacts directly with the Martian atmosphere, which ejects atoms into space. This effect has even been detected by Mars-orbiting probes. And one other main issue with terraforming the planet Mars is that Earth's magnetic field is much, much higher than Mars is. Mars would require a similar magnetic field intensity to offset the effects of the solar wind at a distance further than the Sun. Unfortunately, the technology for inducing a planetary-scale magnetic field does not exist at this time.